Hello, namaste, welcome back to the class. In today's lecture, let us look at the second type of data model, that is nothing but a raster data model. In my previous class, we looked at the vector data model, the two types of vector data model, that is spaghetti data model and your topological data model. Spaghetti has its own disadvantages in terms of not having the topological information, whereas your topological data model has its topological information embedded into it. That is why the topological data model is quite better, but it is quite complex, whereas spaghetti data model is quite simpler. So, this is what we learnt in the previous class. We also looked at what do you mean by an attribute data and why do you need an attribute data and how do you store an attribute data, especially in terms of avoiding redundancy, and how do you avoid redundancy is through normalization. But in this class, the continued class, we will look at what do you mean by a raster data model, the second type of data model representation in a GIS. We have two types, one is vector, other one is raster. So, we will look at raster data model today. How do you represent a raster data model? We will also look at a quad tree model. It is a type of a raster data model. We will see what it is also called Q tree or quad tree. So, we will look at this kind of model. How do you convert a raster and a vector data models? There are you can always convert a raster model into a vector model and a vector model into raster model. We will look at how it is, and lastly we will also end by this particular class with a comparison between a raster and a vector. It is extremely important because when you are generating a data, the user should understand what do you mean by raster and what do you mean by vector, what are the advantages of that model, what are the disadvantages of that model. Without knowing this, the implementation of the data model is extremely incorrect. So, let us understand that in the same lecture. Now, when we are looking at the raster data model, raster model represents a reality through a regular cell pattern. When I say regular cell pattern, on your right hand side, this, if you see, this is a satellite data of a particular region. So, you have, if you zoom into this region and if you can maximize, when you see, it is a collection of nothing but cells. Okay, these are called pixels. It is a bounded boxes which has certain gray value shades. Okay, when I look at the black to white shades that are there here, so each of these shades are representing certain values that are being represented here. The maximum value is 255 and the minimum value is 0, which means to say 0 is representing black and the maximum value is representing, that is 255 representing white. So, anything between 0 and 255 is represented between black and white. Okay. So, when you are representing this, each of these value refers to the amount of reflection from the objects on the earth surface. That is how we distinguish different objects on the earth surface. Okay. So, because it is a continuous data, we refer to it as a field. Okay. So, when we refer to this individual boxes, it is referred to as cells or pixels. Okay. A cells can be organized into a matrix of rows and columns and is also called as a grid. We had studied this in our previous module. It is a grid. Okay. Each grid contains cell with the numeric values attached, and these represent some kind of geographic phenomena. It can be a physical variable such as precipitation and topology with amounts and elevation assigned to the cells. So, each, if for example, if it is topology, it would have been the values of the topological variations that are there on the earth surface can be is associated here. If you are actually looking at any of the maybe emitted or reflected energy as a function of wavelength of a satellite data, then this is the amount of reflected energy that is actually captured by that satellite data. Okay. So, it can be even land use with cell values from the classification system. Okay. So, it can be any other thing that is being represented, but it is a continuous data. Okay. So, when you look at a continuous data represented as a discrete data, if you see this, each of this value have a discrete value. It is always a continuous data that we obtain, but we convert it in a discrete cell values. Okay. Raster data model, the single cell may be assigned only one value. So, dissimilar objects and their values must be assigned to different raster layers, each of which deals with one thematic topic always. Coding raster data is based on numerical and sometimes text codes are also assigned. Fine. So, raster data model represented as a set of large and small set of cells. It can be large set of cells or a small set of cells. That is how you represent normally a raster data. Large homogeneous area can be represented by a single large cell, and similarly finer detailed region will with a smaller cell. So, that is how we group the larger region versus the smaller region. The representation, this kind of representation is called as a quadtree. We will see how it is done, but as of now, when you look at a raster data model, it has to be it can be numerical, it can be some type of text codes. It must be assigned to different raster layers. For example, if you have number of layers, each of these layers are representing some dissimilar values in the entire the real world model. If you have a real world model, each of these layers are representing. I did show you in the previous class. So, when you look at the quadtree is extremely good in terms of compressing the data as well as saving space in the original grid. Quadtree data structures can be used efficiently in terms for saving the data. Quadtree raster encoding recursively subdivides a map into quarters to define a boundary or an area. It means every map is divided into quarters. I will explain this in my next slide, how does it divide and how we will understand the division. The available data quadrant is again split into 4 half size quadrants and so on until the individual pixels is reached. For example, when we look at the next this one, if this is the entire image that we have considered, if this is I am representing this image in terms of a quadtree raster data model. Okay. First what it does, it draws it into 4 equal coordinates, that is A, B, C and D. Now you have 4 different quadrants. Now once we have 4 different quadrants, what it does, for example, let us take this particular quadrant of B. Now this particular quadrant of B is then divided again equally into again 4 different quadrants, that is B1, B2, B3 and B4. Now also it has not reached individual cell, but it is a collection of cells. If you take B1 is a collection of 4 cells, 1, 2, 3, 4. Okay. Now if you go into the B4 quadrant, so now B4 has B41, B42, B43, B45, B44. So this, once it has done the B1, B2, B3, B4, then it takes individual quadrants and again divides into 4 different quadrants. So it becomes, it then drills down to this particular thing which is a pixel. So from an image to a pixel is how this quadtree model works. You have a node, okay, node is this entire image, okay. So this node is then divided into 4 quadrants, which is A, B, C and D. Okay. Now if I take the B quadrant, it is again divided into B1, B2, B3 and B4, which is here, and each of these B1, B2, B3, B4 is then divided into B11, B12, B13, B14, similarly B41, B42, B43, B44. Okay. So now B41 is representing 1 pixel, B42 is representing 1 pixel, B43 is representing 1 pixel, B44 is representing another pixel, and these are individual pixels. So this is how the quadtree model actually stores data. Okay. What are the advantages of, if we look at the quadtree model, there are huge amount of advantages that are there. For example, rapid data manipulation because of homogeneous areas are not divided into smallest cell used. So you can look at data manipulation in a very fast way. Rapid search because large homogeneous areas are located higher up at the points. So if you look at the homogeneous areas are somewhere here, okay, but these are heterogeneous spaces that you may find. So that is how you that is one of the advantages of a quad-tree model. Then you have a compact storage because homogeneous squares are stored as units. So, when there is a unit, it is the storage is extremely efficient, that is why the quad-tree model is quite advantageous. Efficient storage structures for certain operations including searching for neighboring squares or for a square containing a specific point. If you are looking at a specific cell, then for example, let us say someone wants to look at a specific cell which is actually representing a specific quantity or quality on the earth's surface. So, in order to point out that specific cell, it is much easier in a quad-tree than looking at searching in the entire database. That is why it needs, but there are certain disadvantages. Always, as always, establishing the structure requires considerable processing. So, as I explained, the entire structure needs extreme processing capability. Then protracted processing may be prolonged, alterations and updating data entered must be relatively homogeneous. This is one very important disadvantage. Data entered must be relatively homogeneous. Then you have complex data that may require more storage capacity than the ordinary raster data. So, when you have the complexity that is increases in the raster data, then you may need certain amount of storage, higher storage capacity, but always quad-tree model is quite good in representing your entire or minimizing the storage requirement for your entire data to be stored, raster data to be stored. Now, once we have stored both, once we have understood both a raster model and a vector model, so the next thing is, can we convert the vector to the raster or a raster to a vector? Here, when we are looking at it, this particular image on your left hand side is representing a vector data model. If you see, this is a road, okay, this is a building, okay, building is a polygon, there is a set of points that is represented here, okay, and this is another polygon and this is another polygon here, okay. So, this particular house or this particular house is also in between this particular green polygon. So, that is about a vector data. Now, if we have to convert this vector data, so you need to know a process called vectorization, okay. So, if you are converting a vector data to a raster data, it is called vectorization. If you are converting a raster data into a vector data, it is called rasterization, okay. So, when you are looking at this kind of conversion, you need certain things to be kept in mind, that is what we will look at. So, when for example, you have this to be converted to pixels, so you should know what is actually the resolution of that particular conversion you are actually looking at. For example, I will give you complete details of how you convert raster to vector and vector to raster. Let us say this is the raster data that you have considered, 1, 2, 2, all of these are representing different land use classes in this particular image, okay. Let us say we have 4 land use classes, one is urban, one is plantation, other one is water, other one is forest. So, please keep this in mind, because many of them, when you are converting from a raster to a vector, vector to a raster, you go wrong when you are looking at how do you convert a vector to a raster, okay. So, please listen to it carefully. Each raster is assigned an attribute value. I said attribute information is extremely important, okay, and that attribute information can be urban, plantation, water and forest, as simple as that, okay. Now, boundaries are set up between different attribute classes. So, if I consider 1, 2, 3, 4 as attribute classes, so you draw boundaries something like this, okay. Number of polylines, this is the first polyline from the starting node, second polyline, third polyline, fourth polyline, fifth polyline and fourth and the final polyline. All of this polyline will be only set up as a boundary where you have only similar information. If you, let us say, if all of these are 1, so this polyline could have been done something like this, but there is set of 1s here, there is set of 1s here. So, both of this will belong to the same vector data or the vector entity, okay, which is nothing but urban. So, you draw boundaries across 1, boundaries across 2, boundaries across 3, wherever it is found. If it is found in a continuous the pixels that are continuous, draw it as a single boundary. If it is different, you have 1 2 3 2's here, 2 2's here. So, each of this will become a polygon. Okay. So, based on that you draw the boundary. Once you have drawn this boundary, this each of this can be converted as a polygon, line or a point. So, a polygon is created by storing x and y coordinate for a point adjacent to the boundaries. Okay. So, that is how you do it. Let me give you some example of how do you convert a raster data to a vector data. So, let us say that you have this particular image of a raster image or satellite image. So, here let me go back and come to this. So, if you see this, the raster data, then you have a vector data that is put here. Then you start having the same, this is a polyline I am trying to draw across. Okay. Once you have drawn this particular polyline, then I start looking at the number of points that are a polygon. See, this is a similar point, I am drawing across a similar point. Okay. So, it is number of polylines from this polygon. You have another polygon here detached. Okay. Now, it becomes a, it is nothing but your entire vector to raster. Let me show it to you again. So, you have this is the first feature that I am trying to digitize. It is a road across here, this is a road. Okay. You have 2 polygons, 1 polygon here, 1 polygon here. So, you draw this polygon first and you draw this second polygon. You can also draw this as another road, connective road, something like this. Okay. So, that is up to you, but I have just shown 2 parts of it having a line and a polygon. Okay. So, I hope everyone have understood how do you convert a raster data into a vector data. So, just let me show it to you again. So, this is a number of grids that are there. So, you start placing it like this and you go on digitizing it. I spoke about how do you digitize in my previous class. Then you are digitizing it, this lake, this water body here. Okay. This is the first water body and you have the second water body that has been digitized. So, you have 2 different polygons that have been digitized and can be used as a vector data. Fine. So, now if you have to convert a vector to a raster data, raster is a coded polygon, sorry, vector is a coded polygon. A grid with the right cell sized overlays the polygon. The polygons that contain the center of the individual cells are identified. For example, if this is the real world, okay, and this is a vector information. Now, you overlay the cells that on a polygon. The polygon here, the size of the vector information is equivalent to the size of a raster cell. Each cell is assigned to an attribute code of a polygon to which it belongs. Okay, I have already shown how it is done, but just to signify how the attribute code it belongs. For example, first we have converted it as a boundaries. Once you have converted it as a boundary, then you convert it as a polygon. Fine. So, to give you how do you convert a vector data to a raster data, for example, if is something like this. Okay. So, this is a vector data. If you remember, this was a vector data, now this was a line. Now, you overlay that particular as a grid. See, these are different cells as a grid and both of them will have the same coordinate system, they have the same projection and the same way of looking at it. So, now this particular line is then converted into a feature that is in form of a pixel. You can see here every line is nothing but a pixel that has been put here. Okay, that is how you convert a vector data to a raster data. Okay. So, now when we look at vector data and a raster data, there are certain issues that is very important that you understand. For example, when you look at data collection, always a raster data is extremely rapid in terms of data collection. Okay, you have various source of data, you have informations that are easily accessible. So it's easier, fairly easier in order to collect a raster data. But when you look at a vector data, it's extremely slow, because you should understand the quantities that are there on the ground and collect each and every quantity in the terms of point, line and polygons, and each in a different layer. So that becomes extremely difficult in order to have a vector data. But when you look at the data volume, raster data has huge volume of that or the storage space that is required in your entire database, whereas vector data is quite small, it is quite easily storable. So that is why you have a large amount of vector data. I mean, most of the data is stored as a vector data than a raster data. And when you look at graphic treatment, for example, I was giving you an example of land use, okay, in my previous slide. If you look at that particular slide, you can understand that it is easier, or it is much easier to understand a graphic treatment in a vector data than in a raster data, because raster data is not very smooth, it does not give you distinction between two objects or two phenomena, whereas vector data gives you a clear distinction. And in terms of data structure, raster is quite simple, whereas vector is complex. We have spoken about quadtree, and we have also looked at the topological data model. If geometrical accuracy, always raster data has a low geometrical accuracy, whereas vector data is quite highly accurate data collected from the ground, if you have if it is a primary source. And analysis in the network, it is quite poor, because raster data itself has a great data volume. So loading you should have a high computational capability and extremely good network, otherwise analysis in a network is quite poor, whereas vector data analysis in a network is quite good, because it is small data volume and much easier to analyze. And whereas area analysis is much easier in terms of a raster data, area analysis can be done, whereas vector data, its average, or I can even say it is not below par many times. But when you are looking at generalization, raster data is simple. If you are generalizing the raster data, then it is quite simple, whereas the vector data, it is extremely complex in terms of generalization. And coming back to the summary, we looked at the representation importance of various data models. Very importantly, we looked at raster data models and a vector data model. But in this particular session, we looked at raster data model. We said it is a collection of number of pixels or areas, and these in the form of a matrix with m cross n number of rows and columns, and this can be represented in a quadtree data model, very efficiently used. So how does a quadtree work? First it divides the entire image into, or entire raster into 4 quadrants, one then gets into that quadrant, divides again into 4 different quadrants, then gets into that particular quadrant and digs deep until it reaches a single pixel. So that is how a quadtree data model works. Then we have looked at how do you convert a raster data to a vector data and vector data to a raster data. So it is extremely easy to convert to any kind of data that you need. It depends on how do you have to represent your data. Okay. So if you are working completely on the raster database, or having entire data set in the raster rate, it is much useful to have a raster data for every values. If you are working on a vector database, then it is much useful to have a vector database in the entire model. So when you are looking, when you are doing conversion between a raster and a vector data model, you have analyzed how it converts a raster to a vector data. So raster to a vector data is in the form of a boundary, it builds up a boundary, then it converts based on that particular whatever the attribute value is there. I gave an example of urban vegetation, water and other categories. So it converted into 4 category vector data. Then you have vector to raster conversion, wherein you can see that each of this vector is the raster to vector, vector to raster, each of these areas is then converted as pixels. Now then you have raster to vector conversions, wherein each of these rasters you will have to digitize and put it and give it an attribute value or give it a value, and then it is converted from a raster data to a vector data. So, this is what we learnt in today's class. We also learnt about how raster data is better in certain ways and how the vector data is better in certain ways. So, it is up to the user to choose what kind of data model that he or she wants to use in their analysis. So, this is about different data models, how do you use a data model, what are the different ways of handling a data model. So, in the next class we will look we'll dig more into these aspects, and let's meet in the next class. Thank you very much.